Thanks, Ben. Okay, yeah, some really good and valuable information there around hydraulic testing. So the last bit of our presentation today is around preventative maintenance. So for this, we've done this slightly differently. We're not working in the workshop today, but I'm going to pass you over to Ben, who's actually been out on location filming you a whole feature-length session around preventative maintenance on off-highway vehicles. So, over and on location to Ben.
Okay, so we're going to have a look at a few ways in how PicoScope can be used as a preventative maintenance tool, for want of a better word. We're just going to basically take some really non-intrusive tests and actually use them as part of the maintenance procedure in order to actually help us start profiling a machine over time. So at each sort of service interval, we'll just repeat the same tests, therefore bringing the previous captures and actually see if there's a difference between the one captured before and the one captured live. So some easy ones to begin with. We'll start with something very, very simple, which is an exhaust pulse test. Now, exhaust pulse is the byproduct of everything. So it's combustion, compression, fuel, air, all of the end product is obviously the exhaust pulse. Depending on what it looks like, how do we know what a known good is? Well, that's where getting a known good is important. We're very lucky that this machine is pretty much brand new. It's a 2022 model and it's only got 1,300 hours on the machine. So it is what we class as a known good. So once we've got this captured, we'll be able to use this going forward and obviously compare with other like-minded machines. So without further ado, we'll get stuck in. So we're going to be using WPS 500 and on range 3. As with everything, we're going to start with the guided test. So we'll open up the test and get the scope connected. So within the software, for this one, we're actually just going to go straight into pressure transducers. So WPS 500, and we're going to be exhaust pressure running. So we're going to load the guide and settings file. We're going to have a look to see how it's set up and obviously follow the instructions, and we'll minimize the screen. Now, on the screen at the moment, we have an example, a generic waveform. So we're looking for sort of a structured repeating pattern. That may not be the case with all of the machines. There may be something slightly different. So if it is the case of you're not sure, obviously the known good from a machine that you can get to is where it's vitally important. So WPS 500 is set up and calibrated and switched on. We're going to use the exhaust probe and we're going to just fix it into the exhaust. So like I said, a very simple test. Tuck that down in there. We'll start the capture. Now we can see how we've actually got probe mismatch appear because the scope we're using is the BNC Plus version, the 4425A. Actually, we'll be looking for probes that have actually been captured with. Now, WPS 500 is still a BNC only probe. However, we get the probe mismatch to make sure that we have set the scope up accordingly. So, WPS 500 range 3 is what it was expecting. So obviously we just have to match that and obviously ensure on WPS 500 it is on range 3. Once that's been set up, now a couple of little things here. We can actually already see that it's below 0. Now that's not necessarily the case here. So if you ever see that, just pull the transducer back out, switch it off, and then back on again, and that will obviously reset it and recalibrate WPS 500. So now we're back on 0. So we want to be on range 3. There we go. So now we are good to start the test. Put that in there. Right. Quickly run down and start it up. Okay, so we have our results on the screen. You can see that there is a pattern there, but it's not particularly ideal. So what you can do is we can offer just a little bit of pressure to the back of the exhaust. Obviously you don't necessarily do it with your hand if it's up to operating temperature, but something like a sponge in there will actually help. Or we can actually use the scaling feature within the software. So we either use the pinch and zoom on the axis, or on the display tab, we can actually just increase the scale. So like I said, this signal may not look how you're expecting, but knowing that it's from a known good machine, that's really all you need. So once you've got that measurement, you can then obviously look at this in the future and see how things are changing. So a very nice, quick and easy test, and we'll follow this up with some other tests that again are non-intrusive using WPS 500, and we're going to look at the crankcase pressure next. Thanks for watching. Okay, so as we've been sort of saying, this sort of reference waveform or preventative maintenance is based on what does a known good look like compared to one that you're now looking at. So, say for example, we've come to this machine, we've previously captured an exhaust pulse reading, but now we've actually got a potential problem with the machine. So I'm actually going to force a misfire on cylinder 2 in this case. To be fair, it can be any cylinder whatsoever. The idea is we just want to spot the differences between the waveforms and how we can actually do that easily on the screen. So to do that, we literally create a reference waveform from the file that we created previously. So, reference waveforms, channel A was the signal we've created. So then if we drag that one up, so our live signal out the way, we can see we have our reference underneath. Now, if I cause the fault, and now start the capture, again, we're going to need to tell the software that we have WPS 500 connected as we did before, but now we should be able to have the two comparisons. Now, if I stop the capture and we'll just put the machine back right, we can see now that we have a difference in the waveform. So if we pan back through the last 9 buffers, we can see that there is something going on in this area which is different to what we captured previously. So a very quick and easy way of creating a reference in order to actually try and see how that compares to a previous file. Another way to do this is to create a different viewport. So we'd go to Views and Scope, and then what we can do here is actually highlight keep our reference in the top as our known good, and then in Scope 2 we could have our live signal. So again, helping to sort of highlight the differences. Now if we run the software again, we can now see that our reference stays in the top view, and we have all the options now to compare relative to time. We have all our different axes as well, so all of our signal rulers. So just a little quick tip in how to use reference waveforms to compare from previous files. I hope that helps. Okay, so the next one we're going to look at is crankcase pressure. A really important one when you're looking, especially for machine health as they get older and older. There will be some sort of wear going on inside the engine. So being able to sort of plot this against time at each service schedule is actually quite helpful. So again, a non-intrusive test, we literally go in via the dipstick. Couple of points to be aware of are things like things that can affect crankcase pressure. So PCV, positive crankcase ventilation. The type of ventilation system that's fitted may have an impact on your signal. However, if we actually just take in the measurement in the same time, in the same sort of way, then actually we can just use those as comparable results. A bit like a sort of relative compression test, if you like. So because it's done in the same sort of way, it does mean that we can compare the results all at the same time. So in this case, we'll have the machine up to operating temperature, which means things like EGR should be working and should be active, and that way we'll be able to sort of keep in mind how we've tested each time and obviously do the same test in each way. So we'll get the bonnet opened up. And for this test, it is literally just going in via the dipstick. So, we're going to take WPS 500, and we're going to take the flexible pipe that comes with it, connect the two up, remove the dipstick tube, not the whole tube, just the dipstick itself, and then attach in WPS 500. As with all the other tests, we're going to go into the guided test section. So for this, it will be pressure transducers, WPS 500, and we want crankcase pressure running again. So, and guidance settings, tell you how to set the scope up, and obviously it will set the scope up for you in the background, but set the WPS 500. We can minimize that. Again, a generic example waveform on the screen. It may look like this, it may not. So just be aware, obviously we're going to be taking this from a known good machine. So we could say that actually this is the right one for this machine. As again, like for preventative maintenance, we're looking at how we can record a waveform and then compare it again in the future. Okay, so let's get the software running. Again, we need to tell the software that WPS 500 is connected and on range 3. And as before, if we have got some discrepancy in the 0 line, disconnect, switch WPS 500 off, and then back on again, and then that will reset and recalibrate WPS 500 to make sure we're on as 0 line. So range 3, and then we can start the engine. So again, we're looking for a common pattern. We're looking for something that looks stable and even. And again, if we have got some small pulse, then obviously we can use the scaling factor to increase it. So I would say from that pattern, knowing that it's a known good, we can use this going forward and then start hopefully highlighting any problems down in the future where this potentially could start to become a problem. All right, I hope that helps, and then we'll move on to the next test. Okay, so we're going to have a look at a battery starting and charging test. Now this is a new one that's actually in the off-highway section, and it looks at measuring the battery in series. What that means is we can actually do some maths calculations to start calculating the voltage drop across the link lead as well. So for 24 volt battery systems, this can actually be a really quick and easy test in order to actually evaluate the health and condition of each individual battery and how they're performing, as well as the voltage drop across the link lead. So if there's any resistance build up, we'll start to see that within the measurement. The software also has included the measurements for each of the different various components, so we can look at the voltage drop on each individual battery, the overall battery voltage once it's up and running and charging to make sure we're charging at the correct voltage, the inrush current for the starter motor, and obviously the current coming back into the batteries from the alternator as well. So it's a bit of a complete test. It's one that we're quite proud of, and actually we think it's really going to help. So from a preventative maintenance point of view, there's a couple of times when we do this test. So ideally you'd want to do it from a cold start. So very first thing in the morning, so before you've got the machine warmed up, do this test as you crank and start, and that will obviously give you some battery voltage levels as it's sort of sat from cold. And then once the machine's up to operating temperature, do the same thing again. Now the reason being is that obviously oil's cold, it can actually have a bit more of an extra strain on the starter motor. So we might see that the peak current or the peak inrush current will be different between a hot and a cold engine. That can actually help to start give you some ideas about what may be going wrong in the future. Say if you've got slow cranking, it might not be to do with the batteries, it might actually to be do with things like the starter motor, or actually worse, actually something to do with the mechanical side of the engine. So as with all of the tests, we're going to start in the guided test area. So we're going to look at the heavy duty and off highway, and we're going to do 24 volt starting and charging in series. So click on the guidance settings. It will tell you how to make the connection and obviously give you a bit of information as to what's going on. So we're going to minimize that test and then go straight to the actual running system as the capture as it is. So this is up and running already. So you should see we've got our trigger set up. So it's going to be in the falling direction, so on channel A. So channel A is our system total voltage. You'll see that we've actually labelled the channel names with what they actually are. Now the reason being is that when we look at the measurements, they're actually labelled up as they were as for each of the individual things. So we have the system total, the ground side, that's the actual ground side battery, so the one closest to the earth. The starter motor side, obviously that's on the positive side of the battery. So you can obviously tweak those to see how you fit. The link lead voltage drop, now we've obviously going to calculate that using maths. So once the software has done the capture, it will then obviously do the maths on top of it, and then the results will come out afterwards. So we'll get the machine fired up. So obviously the maths will update once the buffer is complete. So we should say I'll get the maths actually do that part of the software, so then we can actually stop the capture and go back a buffer and hopefully we'll have all of our information. So realistically, I'm just going to let that run for a sec. It's not ideal to keep starting these up and then switching them off straight away. But you can see how from a cold start, actually this information could actually be useful. So we have our total system voltage once it's up and running, which is 28 volts, which is exactly where we want to be. Ground side during the volt drop, so during starting was 8.6, and the other battery on the starter side was 8.5. They're about the same. If we had any issues with an individual battery, we might see one actually drop slightly lower than the other, which could start indicating that we have a battery that's failing. The link lead volt drop, obviously we want this as small as possible. We don't really want any drop across that link lead at all. We're down at 300 millivolts, which, 0.3 of a volt is pretty good. Obviously, as soon as that starts to creep up and up and up, maybe we get to like a volt, let's say, that's when we really need to start looking at what's going on there. Starter motor current, we could put another measurement on for the peak, but I'm just going to drag a ruler down, just give a maximum sort of value there. It's about 1.183 kiloamps, so just over 1,000 amps, which is pretty typical. This is quite a big engine. It's a straight 6. There's a lot going on inside it, so it needs a bit of a help. You may find that during a cold start condition that this current is much higher. Doesn't necessarily indicate a fault, just obviously something to be aware of. And then we also have our minimum current, which is our current coming back into the battery once it's started, and that's down at about 100 amps as it starts to sort of plateau out and become more stable once it's up and running. Okay, so I hope that helps. We really like this test. We think it's going to be really useful. Keep using them. Bit of feedback's always good as well, but obviously there's loads that you can get from this simple test and in terms of battery health and starting and charging conditions. Okay, I hope that helps.
Okay, well, thanks for watching. Just the final few slides just to tidy up our presentation today. Anything we've missed, anything you're unsure about, huge amount of information online. Obviously our website, so again it's www.picoauto.com, remember, and also here on YouTube, so be sure to like and subscribe the videos if you can. And then obviously put on that bell sign so when we create new content you do then receive notification. More and more of what we do we try and do on video. I think it's a nice way for you to see, as you've seen today, hopefully, under the bonnet of vehicles and more impressively diggers. So hopefully it's a really, really nice way to connect with you and build your own understanding. I mentioned it earlier, but I really think worth again. Become a member of the forum if you're not already. Go in there. Like I said, there's a heavy duty and off-highway section, and that will really allow you to build your own understanding of issues. And Ben does quite a lot of work on there, well, a huge amount of work on there, particularly with small case studies, and obviously helping as well. So if you've got a problem that you're working on, Ben really is very active on there, and he'll try and help you out and point you in the right direction for good, effective diagnosis. So one final point from Pico Planet, we are trying as a business to reduce our carbon footprint. I think we all are aware now just how important that work is becoming, and certainly the latest IPCC reports show that we have to decarbonise most of what we do. We are getting a little bit stretched now on what was agreed in Paris in 2015. We should be trying to keep our greenhouse gas emissions and global warming below 1.5 degrees, and we are moving vastly towards that, sadly. So we do need to reduce our carbon footprint as a business, as well as we all do individually, by about 50% by the end of this decade. We see extreme weather everywhere, sadly. And things, continue to grow. This is a short graph around motor traffic, particularly. Of course, really important to us in an industry, but it's certainly somewhere where we can have an impact individually by thinking about, every journey that we take makes a difference. So I know Ben, even today, coming into film, has car shared with another colleague, and I think it's just little things like that that really can add up to making a big difference. So yeah, hats off to Ben. and those involved. But let's hope that by communal action, by all of us working together, particularly for lobbying governments, make a difference. Perhaps we can have a more realistic and hopeful outcome for our children. In terms of what we're doing for Pico, we will be net zero carbon, or we were net zero carbon by the end of last year. We will be zero to landfill by 2023. Not easy for a business to make changes. We've had to make big differences in the way that we operate, particularly around business travel. So we're not flying around the world as we were prior to COVID. We are now doing a lot more of our video calls online. Our meetings with customers are online, and it really is working very, very well. In terms of how we operate a business, we have a super insulated building now, so we're not using carbon that we don't need to, and we've also got a huge solar power installation up on our roof as well. So there's a huge amount going on here. If you are interested, and I really hope that you are, please do look on the environmental page on our website, and that takes you through everything that we've been doing and are also planning to do. And remember, Pico is part of the solution. You know, for every part that we test that is repaired rather than replaced, we are making a difference. So rather than throwing it in the bin, you know, let's try and make sure we're doing good testing. We understand the root cause of the problem, and working with Pico is part of that. So that's the end. Sadly, from myself and Ben, would just like to say, you know, a huge thank you for watching. If you made it to the end of these video presentations, thank you. Hopefully it's been useful. Various ways to get in touch. Like I said, Ben's really active on the forum, and you can go on the website Pico Auto and you can see ways to contact us here. So thanks again, and all the best for the future and working with Pico effectively. Goodbye.